Okay, so in the previous two classes, we saw the behavior of light when it passes through a slit, whether it's a double slit or a large number of slits on a glass plate. We saw interference fringes, and how we describe these interference fringes is what we basically covered in the previous two classes. So just to summarize what we saw in those classes, so this is what you see, a laser just shining on the whiteboard. But now if I put a diffraction grating, which is this, which has 600 lines per millimeter, which we saw in the previous classes. So if I put that, so this is what you see on the screen due to the diffraction of the laser beam when it passes through this diffraction grating, which has about 600 lines or slits per millimeter. So this is due to the wave nature of light, and waves do interfere, and those interference of waves gives you these bright regions and dark regions, bright and dark regions. Okay, so this is what we have studied so far, the wave nature of light. So next what I'm going to show you is what happens when we shine a flashlight, which is a white light that you see here. Nothing is along its path. But what happens to this white light if we send it to the same diffraction grating that we use for the laser? So this is what you see when you shine a white light, which consists of the 7 different colors, when you shine it on a diffraction grating. So each wavelengths of light are going to diffract at different angles. So you see the rainbow colors here and here. So these are the first order, and this is the 0 order. And you can see on both the left and right side these higher orders of diffraction. Again, this is due to the wave nature of light. So what we will see next is what's going to happen if we make the slit widths bigger, much bigger. You know. All right, so now what I'm going to use is this slit. You see how big is the width of each of these slits on this plate. So this is what you see in a dark room. You don't see those rainbow colors that you saw in the case of a diffraction grating, where the slit's width is comparable to the wavelengths of the lights. But here you don't see those rainbow colors, and which shows you that there is no interference of light here. Okay, so next what I'm going to show you is for a different light source. Earlier we saw with the flashlight and the laser pointer, but now I'm using a small incandescent light bulb. What you see here on the screen is the light coming from this incandescent light source. That's a point light source. And I want you to see what happens when I put the slit plate with a bigger width, this one, in front of the beam, in front of the light. So that's what you see if you put the slits with a bigger width. Now I'm going to remove that, and I'm going to put the diffraction grating. So this is the diffraction grating. You already see the effect, but let's put it here at the same position. You see the different colors of lights that make up this white light. And that is due to the interference happening when the light passes through the diffraction grating, which has a very, very narrow width compared to what we saw here. So This one has a bigger width, but this one has a very, very small width.